So scale factor, that's the fancy definition. More relatable definition, what you multiply by. Multiply the sides by, basically. So when we dilate, we're going to multiply by a number that makes it bigger or a number that makes it smaller. We either stretch the shape and make it larger, a larger version of itself, like like in Ghostbusters, whenever the Marshmallow Man gets, I don't know, whatever he's called, but that's what I call him. The Marshmallow Man gets really big. Or we shrink, like in Honey, I Shrunk the Kids. These points. A is -8, 2. That goes left 8 and up 2. So left 8, remember we always start the origin. 1, 2, 3, 4, 5. I'll use this.
Only 7.
Yeah, I know. 2, 3, 4, 5, 6, 7, 8, and up 2. So it's going to end up like right here. So I'm just going 1 square off the grid because I messed that up whenever I made this set of notes. It's not normal to have a grid that goes up to 7. Normally they're a little bit bigger, and this is why you check your work before you print things out for the entire school, okay? Entire 8th grade. So it's a little bit off the grid. It's just 1 square to the left, but then it goes 2 up. B is left 2 and up 8. So left 2 and up 8. Start at the center, 1, 2, and up 8. 1, 2, 3, 4, 5, 6, 7, 1 off the grid. We're going rogue today. It'll be okay though, because whenever we shrink it, it will actually fit on the grid. And then C is 0, 4. Now, some of us are still struggling with this. This is don't move left or right, and then go up 4. It is not right 4. If the first number is 0, we don't move left or right. So here is C. It'll look similar to what we did last week, just slightly different shape, or slightly bigger. So go ahead and connect those dots. Now we've been using patty paper. We cannot use patty paper for this because the shape is going to change size. But its dilations, I think, are pretty easy. I think you might find them pretty easy too, as long as your multiplication skills are on point. Okay, let's read what it says. It says shrink your shape by a scale factor, so that's what we're multiplying by. That means that our sides are going to get half the size. Shrink your shape by a scale factor of 1/2. Do this by multiplying all the points by 1/2 and rewriting them. Okay, so since we have a spot to actually write the new coordinates, you see it right here by number 4, I'm going to do it right there. You could also rewrite the coordinates right underneath the new ones, or the old ones, I mean. So we are multiplying all 3 points by 1/2. Multiplying by 1/2 is the same thing as dividing by 2. Okay. So A prime, the original A was -8, 2. So let's multiply that by 1/2, or divide both numbers by 2. Francesca, what would I end up with? X, so we just divide it by 2 or multiply by 1/2, so it's still going to be -4. And then, Juwan, what would the y coordinate be?
1.
Yep. So we multiplied A by 1/2. And in case you're confused where I'm getting that from, I am looking up here at the original points at the top of this page. I'm not just, we have the points written for us, use those. Okay, B prime then. Oh. B prime. We multiply -2, 8 by 1/2. Let's see. Alice, what would my x coordinate be?
-1.
Yep. Jovi, what would my y coordinate be?
4.
Yeah, because 8 divided by 2, or 8 times 1/2. And then C prime. Tyler, can you give me my x coordinate?
0.
Yes, because 0 times anything is still 0. It does not become 0.5 or whatever you try to do. No, it's still 0, because 0 divided by 2 is also 0. And then, who am I going to pick on? Brian, what's my y-coordinate for C prime? Sorry, what? 2. Okay. So now let's read what it says. It says draw your new triangle on the graph with the labels A prime, B prime, and C prime. So now that you have the coordinates, so this is a little bit different. Now that you have the coordinates, graph those three. So you need to graph these three coordinates. -4, 1, left 4, up 1. A prime. B prime is -1, 4. So left 1, up 4. If it kind of overlaps, that's okay. And then C is 0, 2. C prime, I mean. After you're done graphing it, you can kind of check it visually. Does this look like the shape is half the size?
Yes.
The blue shape is half the size as the red shape, which is good. Okay, so let's write down what happened to the points. Well, we know what happened because we did it. We multiplied all the points by 1/2, right? Okay. We could have written divided by 5, or not divided by 5. Divided by 2 is the same thing as multiplying by half. Okay. Now we need a rule to represent this. We always start, remember, x, y. The original points go to, I'm going to give it to you on this page, 1/2 x, 1/2 y. This means, hey, take every point and cut it in half. That's what that means, right? Because you just multiply it by a half, you're representing that. We have a rigid transformation when the two shapes are congruent, meaning that they are the same size and shape.
They're not the same size.
Are they the same shape?
Yes.
Yeah? Are they the same size?
No.
So we say no because they are not congruent. They are, though. They are similar. So no because they are similar, not congruent. Okay. No, because the two shapes are not congruent, they are similar. So they are the same shape but different sizes. A is left 2, down 1. B is left 2, up 2. C is right 2, up 2. And D is right 2, down 1. By a scale factor of k equals 3. K is the letter that we use to represent scale factor. Wasn't my idea. That's just what we do. So we are going to multiply all of the points by 3 and rewrite them before we graph them. So let's rewrite our coordinates right here for number 11 since it says what are the coordinates of your new rectangle. Actually, I might do it up here. Boom. So since I have the coordinates listed right there, I'm just going to do it right above it, or right below it. A prime, I multiply all of the numbers by 3, because k is 3, my scale factor. So the first point is -6, -3. Keep them negative. Someone raise your hand, give me B prime. if we're multiplying by k equals 3. Negative 6. 6. The first point was negative. This x was negative, so it should stay negative. Oh, I need c prime. Elise, can you give that to me? Yep. Both were positive. They should still be positive. And d prime. Olivia, what's that?
6, -30.
So if it helps you to write them right below the old coordinates, that's fine. So that's my new shape. It should be 3 times the size as the red shape. We're going to go ahead and graph those 4 points now. So left 6, down 3, that's A prime. Please make sure you label them. Left 6, up 6. B prime. C prime is right 6, up 6. And D prime is right 6, down 3. Whenever you're done graphing it, that shape should look like it's 3 times the size as the original shape, as the red one. First time, so again, A prime is -6, -3. B prime is -6, 6. I'm just copying from the top. C prime is 6, 6, and D prime is 6, -3. Okay, would someone raise your hand and tell me what happened to the points? What did we do? Yep. Multiplied all the points by 3, which means the side lengths are 3 times the size as well. What rule represents this transformation? Anyone want to give it a shot?
XY goes to 3x, 3y.
Yep. Because we multiplied the x and the y by 3. No, because they are not congruent. They are similar. Okay, last 2 questions, and you have questions like this on your homework, so we need to make sure we understand them now. What is the area of the original rectangle? Remember, the area is just the amount of space on the inside. So area of the original rectangle, the one in red, I'll let you do the second one. You could just count the squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you can do length times width. 4 times 3 is 12. So I know that the area is 12 units squared, because I'm counting the amount of squares inside of each rectangle. What would be the area then of the new triangle? We could do length times width if we don't want to count all those little squares. Tyler, what'd you get?
108 units squared.
How'd you get that?
I multiplied 12 by 9.
Okay, so let's go to our new rectangle. So that's 12 by 9. So this side is 12, and this side is 9. So if I do 12 times 9, mental math, I get 108. So the area is 12 times 9, which is 108 units squared. Ooh. Fun fact, you go from 12, so if you want to, here's what happens with the area. Instead of just multiplying by 3, it actually multiplies by 3 squared, which is interesting, which should make sense because area is squared. So everything else increases by 3, but the area is increasing by 3 squared. I'm not going to expect you to know that, but you could save some time on your assignment if you know that it's just the scale factor squared.